Good afternoon. My name is Manuel Arenas, and today I'm going to be talking about converting municipal solid waste into methanol. So we're converting municipal solid waste into a product-grade methanol, and the municipal solid waste is everyday trash that gets thrown out by people. It includes anything from cardboard, food scraps, metal, all sorts of things. So in order to convert it into methanol, we use a two-stage process. The first stage is synthesis gas production, in which we convert the solid waste through synthesis gas using a gasifier, and then the second stage is the methanol synthesis, which converts the syngas into a product-grade methanol by utilizing a reactor that I'll talk about briefly. So for the syngas production, we first take the municipal solid waste and send it to a RDF facility, which means refuse derived fuel. And in that facility, they remove all the non-combustibles from the waste to increase its caloric content so that it can burn more easily and produce more synthesis gas. The synthesis gas is produced in the gasifier. The gasifier is run at around 800 degrees Celsius with air and steam, and then the synthesis gas is sent to the methanol synthesis part to make the product. So in the methanol production facility, we first run the syngas through a multi-stage compression and cooling reactor to get it to the appropriate temperature and pressure. And then we send it to a water gas shift reactor, which utilizes a copper catalyst to shift the hydrogen to carbon monoxide ratio from 1:1 to a 2:1 ratio, which is more favorable for methanol production. After that, we send the proper ratio of the thing to the membrane reactor, which utilizes a palladium and silver membrane. And in the reactor, the concentration of methanol product increases from 3.7% in a typical process to around 8% in our process. And then the water and methanol are separated by distillation at the end, and the green methanol product is produced. Another interesting aspect of the membrane reactor is that it utilizes a palladium, which is 100% selective for hydrogen to remove the hydrogen from the syngas. And then it increases the mole fraction, like I said before, from 3.7 to 8% in the outlet stream of the reactor, compared to a typical coal or steam reforming of natural gas. And then it also lowers the distillation energy consumption by 16.4%. So in terms of the environmental and energy requirements for this process, our membrane reactor emits around 4,400 tons per year of carbon, and that is a 4.5% decrease from a traditional process in which you either gasify coal or use the steam reformation of methane. And then in terms of energy consumption, the membrane reactor process utilizes 30,500 kilowatts of energy, which is a 32.4 decrease from a traditional process. So this process utilizes a waste product as a feedstock to produce a product-grade methanol, which can then be utilized as a feedstock for many other products such as formaldehyde, acetic acid, or even in the generation of biodiesel. Furthermore, the process reduces the carbon emissions when compared to a typical coal or natural gas methanol process, and by utilizing a membrane reactor, you reduce the amount of energy that needs to be supplied by grid power. This process can potentially be implemented in cities with a lot of trash problems and high populations, such as Manaus, Rio de Janeiro, and Sao Paulo in Brazil, Jakarta, Indonesia, and Mumbai, India. Thank you very much for your time. I hope you learned something useful in this video.